Here we have a polar region generated by the graph r equal to sine of 3 theta. And if we go to a graphing calculator and graph this polar graph right here from 0 to 2 pi. So set the calculator on polar graphing and then like a TI calculator and set it theta minimum from 0 and theta max to 2 pi. And we would get a graph like this, and it has three petals. And what we want to do is find the area of one of them. And then obviously we want the whole thing, we can find one and then multiply by 3, and that will give us the area of all three petals. But the problem here is this: if we go from 0 to 2 pi, then we get 3 petals. And so we need to figure out if we where this one petal go from what alpha to beta. And so that's what we need to do. And then also recall when we look at the graph, notice that each petal starts at the origin. That's where the r, the radius, is equal to 0. So it starts, and we need to put this and ends. Once again, when we look at this petal right here, we can see that it starts here and then go around and then come back to the origin of the pole. And then same thing for this one. So each petal starts and ends at the origin of the pole. And at the pole, r is equal to 0. And so to find where each petal begins and starts and when and ends, and we can set r equal to 0. And again, we know that sine of 0 is equal to 0. And then we know that sine of pi is equal to 0. And then we know the sine of 2 pi also equal to 0. So, which means that the 3 theta right here has to be 0, pi, or 2 pi. And then divide both sides by 3, and then we get theta. 0 divided by 3 is just 0, and then pi divided by 3 is pi over 3, and then 2 pi over 3, and then we get 2 pi over 3. And then what we can do is go back to the calculator and then graph from 0 to pi over 3, and see if we get one petal. And if not, then we can try it pi over 3 to 2 pi over 3, and see if we get one petal. And right here the graph is from 0 to pi over 3, which is one petal. And so now we know that one petal starts at 0, at alpha equal to 0, and then ends at beta equal to pi over 3. And so now we have area of one petal and then alpha will be 0, and this will be pi over 3. And then the radius function is sine of 3 theta. And again, for something like this, and then if we use numerical integration method like trapezoid's rule, and then we get 0.2617994. And so the area of one petal, area of this petal right here is 0.2617994.